Elon Musk isn't afraid to spend money on the most advanced technologies for Tesla's factories, with one condition: they must be truly useful. And the Giga Press is the most useful machine Musk has ever brought to Tesla, even though it's not cheap. Tesla's success today is undoubtedly partly thanks to the Giga Press, the game changer that allows Tesla to produce a car in seconds. But that's just the 6,000 tons and 9,000 tons models. The 50,000-ton Giga Press will be even more shocking, capable of producing 12 cars in just 60 seconds. Elon Musk has confirmed and believes that new car models will be placed into this machine, and the production line will be so crazy that no one will be able to get close. So, how does the Giga Press produce 12 cars per minute? Is this the solution for the next generation of cars? Let's explore right now. You might not know this, but the story of Elon Musk and the Tesla Giga Press is quite thrilling. Bringing this machine to the company was no easy feat. According to what we know, the idea for the Giga Press came from an inspiring moment for Elon Musk. Musk once held a die-cast toy car on his desk and asked himself, why can't we do the same with real cars? He realized that casting large parts, like the entire underbody of the Model Y, could significantly reduce weight, cost, and assembly time. At that time, Tesla was under immense pressure to increase the production of the best-selling Model Y, and the company needed to find ways to reduce costs more effectively. The Giga Press was seen as the key to achieving this goal, as it helped reduce the cost of manufacturing the vehicle frame by 20 to 40%. However, building a machine like this had never been done before in the automotive industry, and die-casting manufacturers initially doubted its feasibility. At that point, the automotive industry typically used steel stamping and robot welding to create car frames, which required hundreds of parts and complex processes. Despite the machine's potential, Elon Musk reached out to 6 major die-casting manufacturers to inquire about such a press. Surprisingly, 5 of them declined, considering the idea too crazy and unfeasible. It seemed that hope was lost, but luckily, in the final contact, Idra, an Italian company specializing in die casting, accepted the challenge. Of course, even Idra wasn't entirely sure, and they only said maybe. For Musk, that maybe was a huge deal at the time. To quickly bring the Giga Press to life, Tesla worked closely with Idra for over a year to develop it. The process was far from easy. Tesla continuously requested design modifications, forcing Idra to adjust the machine to meet the requirements. A representative from Idra shared that each time Tesla proposed a change, their engineering team had to work tirelessly to update the design. And in the end, the Giga Press was successful. Tesla started with the 6,000-ton Giga Press to produce the rear chassis of the Model Y, followed by the 9,000-ton machine specifically for manufacturing the Cybertruck. Now, Elon Musk is moving forward with the 50,000-ton Giga Press, dedicated to the chassis of the Cybercab and the affordable Model 2. Compared to the 6,000-ton and 9,000-ton Giga Presses, this machine is far more efficient, as it can cast multiple frames at once, and the casting time has been reduced from 70 seconds to just 5 seconds. Yeah, it sounds unbelievable. We didn't believe it either, but it's the truth.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa, like real fast. And then I guess maybe we need to just get even bigger casting machines. Sure, why not? Down, yeah, let's 50,000 tons.
Okay, so how massive is this machine? How long does it take to assemble? How is it different from the 6,000-ton or 9,000-ton Giga Press? And how can it produce one Cybercab every 5 seconds, 12 cars per minute? These are exactly the questions that popped into our heads when Elon Musk mentioned the 50,000-ton Giga Press. Many people still mistakenly think that the 50,000 tons refers to the weight of the machine, but that's completely wrong. The 6,000 tons, 9,000 tons, or 50,000 tons refers to the pressure the machine generates, not its mass. However, its size is still enormous, and its weight could reach over 3,000 tons or 6.6 million pounds. To put it in perspective, as far as we know, the 6,000-ton Giga Press weighs about 430 tons or 948,000 pounds. while the 9,000-ton version weighs about 688 tons, or 1.52 million pounds. This means that the 50,000-ton version could weigh up to 8.16 million pounds. Yeah, a real beast. Compared to the current Giga Press models, this new machine generates about 8.3 times the pressure of the 6,000-ton version and 5.5 times that of the 9,000-ton version. So, just the installation process could take months. In terms of size, the 50,000-ton Giga Press is 131 feet long, 42 feet wide, and 39 feet tall, equivalent to a 4-story building lying on its side. Sounds shocking, right? Clearly, Tesla had to build a special facility just to house this machine, with a reinforced concrete foundation several meters deep to support its insane weight. If you doubt it, you should know that the 6,000-ton Giga Press alone is 64 feet long, 19.69 feet wide, and 17.39 feet tall. So, the 50,000-ton Giga Press will be many times larger. But how does the 50,000-ton Giga Press work? The Giga Press applies ultra-high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving no defects. Once cast, the part is evenly cooled, causing the aluminum alloy to harden into its final shape. This process requires extreme precision. If it's too fast, air bubbles can form. Too slow, and the aluminum starts cooling before fully filling the mold. The cooling process is carefully controlled through a uniform cooling system, which helps the final product achieve high strength and accuracy. After cooling, a robot extracts the part from the mold, trims off any excess material, and sends it through a quality inspection process. The Giga Press plays a crucial role in reducing vehicle weight, increasing structural rigidity, and boosting performance by casting a single large component instead of welding together dozens of smaller parts, saving both time and labor. Today, there are various types of giga casting technology from multiple suppliers on the market. Aside from Tesla, companies like General Motors, Hyundai, Volvo, Zeekr, and XPeng have also invested in this tech. Notably, XPeng has invested in a 16,000-ton Giga casting machine. The operating mechanism of the 50,000-ton Giga Press isn't entirely different from that of the 6,000 or 9,000-ton models. First, the process still begins with preparing the materials. Tesla will melt down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 degrees Celsius. Then, any surface impurities are removed before the molten metal is transferred via heated pipelines to another sealed furnace, which maintains a temperature between 750 degrees Celsius and 850 degrees Celsius. From what we know, the Giga Press uses a 2-furnace system to process the aluminum alloy. One acts as a melting furnace, powered by natural gas and operating at around 850 degrees Celsius. The other stores the molten metal and is electrically heated, maintaining a temperature between 750 degrees Celsius and 850 degrees Celsius, as mentioned earlier. The empty space inside the holding furnace is filled with nitrogen gas, which helps prevent the formation of oxides in the molten aluminum. It also helps maintain a consistent temperature. Additionally, operators use argon gas, a rotary degasser, and a silicon carbide filter to remove further impurities and particles larger than 25 microns. That covers the material preparation stage. Next up, mold preparation. Before each cycle begins, the Giga Press lubricates the mold surface. A robot sprays around 35 milliliters of soybean oil in a thin, even layer across the mold, kind of like greasing a baking pan, to make it easier to release the part afterward. Then the system creates a vacuum to remove any air, and the molten aluminum is transferred from the holding furnace into the Giga Press's shot chamber. There, the molten metal is injected into the mold cavity by a high-speed piston. That piston is also lubricated with about 8 milliliters of oil before each shot.
In a single casting machine, we could do like 5 at a time or something. I'm trying to think, like, how do you scale castings? Because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
After the aluminum is injected, it's left inside the mold until it solidifies. The casting is ejected from the mold at around 400 degrees Celsius. Then, The raw casting is placed into a cooling bath to quickly bring the temperature down from 400 degrees Celsius to about 50 degrees Celsius. This rapid cooling helps eliminate certain defects and enhances some of the material properties. Finally, the opened mold is cooled down to around 185 degrees Celsius and thoroughly cleaned by a robot to prepare for the next cycle. The next casting cycle typically begins about 1 to 2 minutes after the current one finishes. Any excess metal is trimmed off and recycled for the next melt. The final product is X-rayed to ensure quality and structural integrity. One of the biggest challenges during the casting process is keeping the mold from bursting open under the intense pressure of molten aluminum injection. That's why the machine must apply extremely strong clamping force to hold the mold tightly shut. And with the 50,000-ton Giga Press, that clamping force is absolutely massive.
So I mean, we got to jam the liquid metal in, cool it down real fast, like real fast.
According to Elon Musk, to make this all possible, Tesla had to design an ultra-fast cooling system, a smart mold release mechanism, and an AI-powered automated quality inspection process, a combination of technologies that no other automaker has ever attempted to implement at this scale. This also marks the first time the auto industry is shifting toward a production model that closely resembles electronics manufacturing, fast, streamlined, and with extremely optimized use of space. With the new one-piece casting process, car production has become much simpler. Tesla's productivity has doubled, and costs have dropped significantly. The production line, which used to require 1,000 robots, now only needs 300. We believe that the 50,000-ton Giga Press will bring about a huge revolution for Tesla's new vehicles. Manufacturing them will be faster and much less complicated. In fact, the idea of using the Giga Press was ridiculed by the automotive community. Many believed the technology was impractical, especially since aluminum molds wear out faster than steel stamping dies, potentially increasing long-term costs. However, Musk and Tesla have proven the opposite. It's no coincidence that Ford, Hyundai, Toyota, GM, and Volkswagen have also spent money to buy the Giga Press, all recognizing how much Tesla benefits from this machine. Producing 12 cars per minute or 720 cars per hour completely changes the way cars are made, something no competitor has been able to achieve. This is perfectly aligned with the Model 2, as Elon Musk confirmed that this car will have a massive production volume, surpassing the combined total of Model Y and Model 3. Switching to some other recent updates, Waymo has recently suspended its autonomous taxi services in certain areas of Los Angeles and San Francisco due to ongoing violent protests. The protests erupted in Los Angeles and San Francisco against the Trump administration's immigrant crackdowns. The most alarming incident occurred recently when several Waymo robotaxis were severely vandalized, with at least 5 cars caught in the line of fire, and at least 1 car was completely burned. When these cars caught fire, toxic smoke from the lithium-ion batteries was emitted, which could affect health, prompting the police to advise people to avoid the downtown area. The cost of these attacks is notable. Each Waymo robo-taxi is valued at between $150,000 and $200,000, according to a 2024 report from the Wall Street Journal. Switching to other news, the Tesla robo-taxi service is getting very close, and we will soon see autonomous vehicles operating on the streets of Austin. A recent video posted on X has provided the first glimpse of Tesla's robo-taxi, which is expected to be deployed in Austin, Texas, this month, with a major event scheduled for the 12th. It's clear from the short clip that Tesla's robo-taxi operates completely without a driver. We believe that Tesla is achieving extremely high reliability for its robo-taxi service, and it's quite exciting to think about next month when Tesla will allow more customers to test them instead of the limited number this month. What do you think about the future of these self-driving vehicles? In other news, the Tesla Model Y has solidified its position as the best-selling SUV in China for May, with 24,770 vehicles registered. It surpassed competitors like the BYD Song Plus, with 24,240 registrations, and Geely's gas-powered Xingyu L, which ranked third with 21,014 registrations. Although Tesla's Q1 profit dropped by 71%, which led many to believe that very few Model Ys were sold. We were mistaken. In the first 5 months of 2025, Tesla sold 126,643 Model Y units in China, surpassing the BYD Song Plus with 110,551 units and the BYD Song Pro with 80,245 units. This is quite an impressive number, especially considering the Tesla Model Y remains a premium vehicle, much more expensive than many of its competitors. Although the Model Y is the champion SUV, Tesla's year-over-year performance in China is still facing some challenges. Total sales for May were 38,588 vehicles, a 30% decrease compared to the same period last year. From January to May, Tesla delivered 201,926 vehicles in China, a decrease of 7.8% compared to the same period last year. However, these declines were significantly impacted by the company's transition to the new Model Y in the first quarter. Hopefully, things will be stronger in quarter 3 and quarter 4. What Tesla is doing with the Cybercab isn't just about building a car without a steering wheel or pedals. It's about reinventing how cars are made. It's not just about redesigning the vehicle, but reimagining the entire production process. Instead of a traditional assembly line, it becomes a network. Instead of human workers, it's robots. Instead of hand-assembled parts, it's stacking pre-made modules together like Lego bricks or toy blocks, just like Elon Musk said.
And that's actually kind of how they do it in like small volume castings. They'll have a casting block that'll make 100 Matchbox cars at a time. Maybe we just make that real big. Yeah, we have the cathedral of casting back there.
Yeah, Elon Musk actually compared producing the Cybercab to making toys. The only difference is that Tesla is scaling up the machine to build as many vehicles as possible. Once the Giga Press finishes casting 5 Cybercab chassis, they're immediately fed into the unbox process line, a system so fast that, as we mentioned earlier, humans can't even approach it safely. This machine can cast 5 car bodies simultaneously, which means the mold is significantly larger, and the casting process becomes far more complex. The metal has to travel longer distances within the mold, increasing the risk of defects. As highlighted earlier, if the injection happens too fast, it can trap air bubbles, weakening the structure. But if it's too slow, the aluminum may begin to solidify before the mold is fully filled. All of this takes place inside a 50,000-ton machine. So naturally, Tesla needs time to transport, install, and fine-tune the Giga Press before it can go live. Recognizing the leap Tesla has made with this efficient production model, many automakers, like Toyota, General Motors, Geely, Volvo, and Hyundai, are now trying to follow suit. However, most are still only starting with 6,000-ton Giga Press machines. So if Tesla already has a 50,000-ton Giga Press up and running, when will the others be able to catch up? Thank you for watching our video. If you found the content helpful and want to explore more exciting information about Tesla EVs, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.